Welcome to my talk, Sanitize client-side, why server-side HTML sanitization is doomed to fail. Now, before I begin, let me just get a quick grasp of the room. Who here think it's weird when they hear the sentence sanitize client-side? With a quick show of hands. Okay, so some of you. And I agree, it does sound weird, like at first glance when you think about it. But I hope we can learn something new today and maybe even change some minds. So a bit about myself. My name is Yaniv. I'm a vulnerability researcher at SonarSource. If you're not familiar with Sonar, we are the home of clean code. We help developers write clean code, which in the context of our talk today also means secure code. So before I get into the actual topic, let's have a small recap on the XSS bug class. So an XSS is when an attacker has the ability to inject JavaScript code into a vulnerable web page. And the most commonly used example that you will see is when we have a web server that, let's say, hosts some comments from user. A user can come in and write a simple comment like, hello world, and post it into the web page. Now, then this web page will host that comment and everybody else can view it. But on the same note, an attacker can come in and write a malicious comment and then post it to the same web page. But if the server does not handle the user input correctly, next time a user will view that page containing the malicious comment, an XSS will trigger and JavaScript will execute in the context of the victim. But what I mean when I say they do not handle this comment correctly, so if we take a look at the most simple example of an XSS vector, this one is simply an image tag with an on-error event handler. So that means if there is an error to load that image, it will execute some arbitrary JavaScript code. Now, a web server can fairly easily just escape any character that has a meaning in HTML. So in this specific example is the lower than and greater than sign, but then it means that what the users will see is literally the text that you see here on screen, which could be fine in some cases. But sometimes, I mean, more often than not even, applications will actually like to support some HTML features. And so, for example, they want to have like titles or bullet points or even support images. So they want to actually get from the user some HTML input. But in some way, they need to, on the one hand, support some HTML features, but on the other hand, make it safe and not render any JavaScript code. And you can imagine as if they want to allow more and more features, then the potential for an XSS rises. And yeah, sorry, that's the, anyway. So what's the common mitigation for that? And usually what we will see is something that's called sanitizers, which are meant to solve exactly this issue. So sanitizers are meant to get an untrusted input from the user, and in some magic way, make it not XSS, like not run any JavaScript code. But how does that magic work? So let's simplify matters. At first, it gets the untrusted input from the attacker, which at first is just a string. It doesn't mean anything. And it needs to understand it in a smart way to know how to manipulate this data to make it safe. So at first, it needs to parse it. And after parsing, the results will be a structured object of the document itself, which is called DOM tree. So now we can see like which element is a descendant of which element, what attributes we have, etc. And the second step that sanitizers can do is now iterate over that object and see what we want and what we don't want to have in our markup. And in our cases, they can look and see, okay, we have an on-error event handler that can execute JavaScript code. Let me just remove that, and then I can pass it along to the user, and everything should be safe. Now, it's important to mention that some websites would like to support, for example, images, but others don't. So, so sanitizers are highly configurable. A user can come in and say, I want those elements and those attributes to allow, and the others don't. So yeah, you will see that come into effect later. But yeah, also something to know that sanitizers at the end are just a piece of software. Like any other software, they can have bugs. And in the worst case, you can bypass that sanitizer and have an XSS. But what does it mean? What's the impact of XSS? Well, it highly depends on the application. Because the XSS is triggered and executed by the victim, it highly depends on the capabilities of the application, what the victims can do in that application. So it doesn't really imply directly on the impact. It can have no impact at all, but it can have also data leakage, as we saw before, account takeover, even full-on RCE. Yeah. So now that we have that introduction behind us, what do I mean when I say you should sanitize on the client side? So if we take a look at this simplified attack flow, we have mainly three nodes. We have the attacker, which is the one that generates the untrusted input, whether it's creating a link or posting a comment. We have the server, which is the node that serves the page containing the untrusted input. And then we have the victim, which is the one that views the page and essentially triggering the XSS. So we have actually two sides, two nodes in the client side. And when I say you should sanitize on the client side, I mean you should sanitize on the victim's client side. Because, of course, sanitizing on the attacker side, attacker doesn't have to obey any sanitization rule. They can just simply not bypass it if the code is on their side. And when we think about server side, like some traditional vulnerabilities like SQL injection, RCE, SSRF, and etc., they're all triggered on the server side. So it's very logical to sanitize it there. But when it comes to XSS, they usually are triggered on the victim side. And then we want to actually sanitize where the vulnerability is potentially executed. But why should we do that? So in order to convey my point, I can start by telling a story. And this story, like a lot of other research stories, it also has taken place in the most secure language known to mankind, PHP. And it all started about a year ago when a colleague of mine sent a message to our Slack group saying, hey, I just found a bypass to a Grav sanitizer. Grav is an open source CMS. Here's a small advisory for you to review before I send it to the maintainer. And me at the time, I was, let's say, familiar to a certain extent with sanitization bypasses and HTML quirks, etc. And so I asked him, did you try those techniques that we shown to be effective? He said no, so I went out and tried to give it a second look on that sanitizer. And after a couple of minutes, I just sent this message saying, hey, nice findings, but by the way, here are some other bypasses, and just dumped a bunch of other payloads. And there could be someone here that is highly familiar with HTML language that can already spot the core issue. And if you do, I mean, kudos to you, because at the time, I did not know that there was one core issue here. And in fact, it was different from what Stefan found. So yeah, seeing that, I told him, if I were you, I would just suggest them to give up and the recommendation to the maintainer. For some reason, he thought I was joking and did not recommend that. But yeah, a couple of days have passed, and I didn't really pay much attention to that. But then I decided to maybe revisit that. Maybe I overlooked something. And what I found was funny to say the least. So it goes like this. Let's say you have an application. That application does not sanitize at all. You have a very simple XSS. So you have one bug. You have impact on one application. Everything is great. But as we said before, more often than not, applications will actually tend to use sanitizers. And a lot of time, they will tend to use a third-party sanitizer. Of course, it's easy, it's out of the box. But that means that if you have a bypass in that sanitizer, you have one bug that can impact multiple, if not many, applications. What I saw is that there were multiple sanitizers that were vulnerable to the exact same payloads. And all of them, the common denominator of them is, if you remember what are the steps of sanitizer, the first step is to parse it. And they were all using the built-in HTML parser written in, from PHP. And it's very it's very understandable. PHP is an application meant for web apps. It's a language meant for web applications. So, I mean, they have a built-in HTML parser, and it's very understandable why Sanitizer will just use it. I mean, it's out of the box, right? But that means that if that parser is wrong or different in some way, you're impacting all the sanitizers and a lot of applications. And on top of that, that parser of HTML was using the shared library to parse HTML that's called libxml2, which I don't know if there's any other parser that use that. Eventually also sanitize it. So it was funny to see like this pyramid of one issue to have a great impact on many applications. But what is that one issue? What is that core issue that we're talking about? So if you look, I pull up some example of the payloads that I've seen like shown before. And if we try to split it to different features of HTML, what we will notice is that those features are actually either new or changed in HTML version 5. And if you're not familiar with HTML version 5, it was introduced a decade ago, and they added a lot of new features that we all use today, and updated some specs. And this is basically what we use when you open your browser, you use HTML5 today. But when adding new features and new updated specs, it means that they also introduced new complication into the language itself. And let's take a look at one example of a differential. The first one, let's take a comment, and let's see how it looks like between those versions. So in the previous version in HTML4, if you pull up the documentation and you see how it should be done, comment should be started with the following string and ended with -- greater than sign. Pretty understandable, pretty straightforward, everything is great. But if we pull up the documentation of HTML5 on the other hand, the first point is the same way. We should start comments the same way, but if you look at the second point, it states that the text must not start with the string greater than sign, -- greater than sign, -- exclamation mark, greater than sign. So we can easily see like a differential between those versions. An attacker now can take advantage of that and create the following payload. And if we take this one and we parse it in those two different versions, you can see that in HTML version 4, everything is commented out. And in HTML version 5, on the other hand, the comment will actually end here. And everything that comes afterward will be just rendered as normal HTML. So a sanitizer that parses with a built-in PHP parser, they basically got the DOM tree object, and they saw only a comment. They didn't see anything malicious here, so they didn't delete anything. But then when they pass it along to the browser, suddenly the browser ended the comment there, and we have an image element that wasn't here before, and that way we can bypass it. Now, just to explain a bit, that means that every sanitizer, or most of them, written in PHP that enable comments or any other feature in HTML5 that is related is inherently vulnerable. You can just bypass it fairly easily, as you can see here. And you might think to yourself, well, okay, Yaniv, that's quite a big impact. And you could be right, but I'm sorry to say that's only the tip of the iceberg. We've seen over the past, we discovered as well, a lot of bypasses that were regardless of the version that the server is parsing. And the main reason, like a lot of times, the main reason for that was that the sanitization was actually done on the server side. And the core issue why it's not a best practice to do that is because parsing HTML is hard. It's a very difficult task, and I will demonstrate it with some examples. So let's take the first example. Let's say we're all using HTML5 in this case. Me, as a server, I parse it and I sanitize it in HTML5. I pass it along to the users. But who said that the users use the same browser? One of them can use Chrome and the other one can use Firefox. Now, HTML is to the level that parsing is not that straightforward, that even between major browsers, there are differentials. And we've seen XSSs that were like only affected one browser or another. But you know what? Let me take it one step forward. We can say all my users are using Chrome. Another thing to note is that HTML is an evolving language, and new specs and updated features are always getting rolled out, and browsers can implement it with one time being. So one of the user can use an outdated version of Chrome that has different implementation of the specs, and suddenly we have another differential potential here. But you know what? Let me take even a step forward and say, let's say we're all using the exact same parser. No question asked, exact same browser parser, exact same version. Here we have another issue that's called parsing round trips. And this issue states that if I, as a server, I take the untrusted input, at first it's a string, right? I parse it, and then I sanitize it. Now I have a clean DOM tree object, for sure. But now I need to transfer it back to the user somehow. And in order to do that, I will need to serialize that object. I will need to transfer it back to text to send it over the network. Now the client need to reparse that string again to have the page. The problem is that when reparsing it, it does not actually mean that they will have the same outcome. They can have a totally different page with suddenly a malicious input in it. So, yeah, depending on the time that you parse it, even if it's the exact same parser, you can have different results. And it sounds weird, but this is the intended behavior of HTML. It's well documented. This is how it just works. So you have all of that. And on top of that, you have some other MXSS techniques, which stands for mutation-based XSS, which we've seen some crazy ones even quite recently. We have some other things to note, like different configuration of the parser, or different context of where you parse it, and so on and so forth. What I'm trying to say is that you can never guarantee that how you parse the content will be the same thing as it will be shown in another computer at the end. There are just too many points of failure. So that's mainly why when you sanitize, you should be doing it where the context is actually being viewed at the end. So I hope my point is clear. Yeah. Let's go back to our story. Talk about a bit of disclosure, because who is responsible? Now, everybody can just point fingers at each other at this moment. And the application can say, well, it's the sanitizer's fault. We're not sanitizing it. The sanitizer can point finger at the HTML parser, which is like, we're not parsing it wrong. And the parsers can say, we're not sanitizing. And you will see that take into effect in a bit. So we decided to go from the top to bottom, starting with libxml2. So we reported it to them, and they said, well, we never claimed to support HTML5. They have an open discussion about it, still open because lack of maintainability, and they asked us to direct the finding to the relevant downstream projects, which, I mean, it's logical when you think about it. We didn't expect anything more than that. So we did. We went to PHP, and PHP said, we are aware we don't support HTML5, and they also had an active discussion about it. And the only actionable thing from their side is to add a warning to the documentation. And that's what they did. So following our reports, if you go and try to parse HTML, you go to the documentation, you can see they have like a big warning that says you should not use that for sanitization purposes. And yeah, from our point of view, that's the best that they could do. So that's great. But when I created this presentation, I also saw that they did actually later implement HTML5 in PHP version 8.4 using another underlying parser. But it does not fix the fundamental issue that you parse it on the server side. As you saw before, like parsing it even in the same HTML versions, there are just too many points of failure. And to emphasize that, I will also give you another example. This one was a third-party library that parses HTML, that claimed to parse HTML5, that was also used afterwards to sanitize data. And they had some differentials. So we reported the differentials to them. They said, well, if other users use our package in a non-safe way, it's not their control. And because of that and lack of capacity, they will not fix it. They suggested that we can just create an issue or a pull request for the community to address it. That's what we did. Still open to this date. Yeah, and also like all of those parser point of view, it's quite understandable. I mean, they're not sanitizing. They did not claim to do anything else. So from my opinion, it's okay. But then if we go back to the sanitizers, so starting with the DOM sanitizer, which was the one originally that used in Grab, we opened an advisory. So it was vulnerable to the default configuration. You didn't need to add a configuration to say allow comments or whatever. Out of the box, it was vulnerable. We opened an advisory in GitHub. They claimed they fixed it and closed the advisory. So when you close an advisory, it's not going to be public. Nobody knows that it was vulnerable or how it was fixed, etc. And in fact, their fix didn't address our finding at all. The exact same payloads that we shown in the advisory were still bypassable. We asked them to reopen the advisory. We got no reply. The next one is HTML DOM purifier. This one was vulnerable to non-default configuration. So you needed to add a line of code that says, hey, allow comments in order to bypass it or allow any other stuff that is relevant to the bypass. The maintainer argued that configuring the sanitizer to allow comments, for example, is like the user allow XSS. I mean, we try to challenge this point of view, saying, if a user allow comments, they expect to allow only comments, but we got no reply. Another one was Magento 2. This one was vulnerable to non-default configuration, and it was never used in a vulnerable configuration in Magento 2. So this one was a bit different. It was more to just raise awareness that in the future they will not use it in a vulnerable way. And they say, well, the parser differential is not actionable, and because of that and capacity issue, it was not fixed. Last but not least was typo 3. So typo 3 was vulnerable to the default configuration, and they were the only one that actually fixed our issue and assigned a CV. Yeah, so kudos to them. But those are only the sanitizers that we looked at. So there are potentially many more considering the popularity of PHP. So yeah, this is it. But when we go down to the application level, the fundamental issue is still here, even if the sanitizers fixed it. I mean, for them, if they parse it and parse and sanitize it on the server side, there are still so many points of failure, so many other ways that an attacker can come up with in order to bypass the sanitization. But what does the future hold? So we have this great story. If you plan to continue sanitizing on the server side, I'm sorry to tell you, it will be still doomed to fail. There is no discussion about it. There is no active initiative or whatever, because we understand that the right way to do it is to sanitize on the client side. And for now, what I would recommend you guys is to use DOM Purifier, which is the most robust client-side sanitization. When used on the client side, it can be used also on the server side, but also in their documentation, they say use it on the client side. But at the end, it's a third-party sanitizer. It still has some issues, and we've seen bypasses, even one quite recent one, which was crazy. Yeah, but for the future, for the bright future, there is an initiative that's called Sanitizer API. This one is a client-side sanitization API built by the browsers themselves. So if it's built by the browsers themselves, it means that it has no differential, context-aware, no parsing, so many other features that hopefully will make it immune to bypasses. At the moment, it's under a feature flag in Firefox, and in Chrome, they rolled it out, it's still under development. Yeah, so I hope the future is bright. And what we hope is, since it will be in the browser built-in, it will be so easy out of the box, it will help developers shift from server-side sanitization to client-side because it will be so accessible. So this is regarding the future. But if today in this talk, we didn't actually delve into the technical details when talking about this like iceberg analogy. If you are interested and you do want to get into the actual how it works, to see technically how it works and how the differential work and learn about HTML, I could recommend you to go and see another talk that we gave earlier this year, a colleague of mine and I. This one was more technical and, in my opinion, a great way to get into this rabbit hole, which in my opinion is very, very interesting. And yeah, and aside from that, okay, well, I kind of skim fast over it, but yeah, aside from that, thank you all for attending, and we have time for questions.